Okay, simple science here. Schrodinger's cat. It's a thought experiment. Keep that in mind. A thought experiment. Oh, and we forgot something. We forgot the diuresis. Let's put the diuresis in. You know those two dots that go on top of the O? Let's put them in. Where's the O? There's the O. Put those. That's what I'm talking about. All right, here he is. Schrodinger's cat. And remember, it is a thought experiment. It's not a real experiment. So let's make that down. Not a real experiment. So let's get started. So again, it is a thought experiment that was formulated in 1935. So Edward Schrodinger was talking to no other than Albert Einstein in 1935 about this thought experiment. So 1935. And in the experiment, he had this box, and I'm going to oversimplify it here. And inside the box was a cat. Right? So I'll draw a little cat here. Here's my attempt of a cat. All right, somewhat of a cat. Smiling cat. What should we call the cat? Let's call him Quantum. Little joke there. Because all this stems from quantum mechanics. And by the way, do not attempt to learn quantum mechanics in one video. And I'm not going to teach you quantum mechanics in this video. Quantum mechanics, as you know, is, well, maybe you don't know, but it's strange. It is very weird. It is the science of the subatomic world. And things happen in the subatomic world that don't seem to happen in our world. That's why it's called quantum mechanics. So that's why the cat's called quantum. So let's just talk about this in a simple nutshell, what's happening in this experiment. So let's say that you put a cat in a box, and here's a box, and it's closed. And inside the box, let's say you put some food that has poison in it. Right? There's the poison. All right. Now, since we don't see what's happening here, the cat either ate this poison or did not eat the poison. Or it ate the poison and it's either dead or alive. So what Schrodinger is trying to say here is that until you open to the box, until it's observed, until it's measured, that this cat is either dead or alive until you open the box. Now, we have to add more to this. It's not just a common sense question where you say, yeah, we don't know if it's dead or alive until we open the box. What it's trying to say here is that it's both dead and alive. So let me say that again. It's both dead and alive until it's observed and measured. So that's kind of crazy, right? So what they call this, and let me give you another example here. Let's clear this out. So let's say we had particles, right? These subatomic particles. And we'll make a little box here. And let's say that there's a particle here, one. Now I'm going to draw the same particle. So we can say that this particle is here, or the particle could be there, or maybe it's there, or maybe it's there, or maybe it's there, or there, right? It could be in any of those places and more. But what this is trying to say, what the experiment is trying to say, is that it's everywhere at once. In other words, until it is observed and measured, right? The particle that we can't see, right, is everywhere. It's everywhere in the box at once. It's everywhere at once, simultaneously at once. So it's in all, but here it is in all possible states. Now, by the way, this is only for the subatomic world. So when we're talking about a cat, that's the world that we live in, which so far doesn't work for this theory of quantum mechanics. All right. Okay, ready for this word that you're going to hear? Now, when it is in all possible states, when this particle is in all possible states, whether it's here in number 1 or number 2 over here or 3, 4, whatever the case is, when it's in all possible states, that's what they call superposition. So you might hear that term, superposition. Superposition just means what I just said, that the particle is in all possible states. So when you do observe it, the superposition will collapse into one state. That's the weird thing about quantum mechanics. All right, so let's look at another example. So let's say that we were a particle. And again, in the macro world that we live on, this doesn't work, right? But again, let's pretend we are a particle, and let's say that we have this universal box that we're living in. And let's just say, we'll use red, we'll keep red. Let's say we're living in New York City over here, there we are, and maybe Montauk Point over here, and maybe we're over here, we're in LA, and maybe up here we're in San Francisco, maybe we're in Salt Lake City over here, maybe we're down in Miami over here, and maybe we're in Erie, Pennsylvania over there, and so forth and so on. Maybe we're in North Dakota, maybe we're in Montana, maybe we're up here in Canada, who knows, right? Well, what this is saying is that we're in all those places at once. So again, what is it called when we're in all places at once? Superposition. And so when someone opens this universal box, the superposition will collapse and we'll be in one state. Maybe we'll be in the state of being in Brooklyn, or maybe we'll be in the state of being in Pasadena, California. All right, that's what basically it's saying. So particles are made of matter. We're all made of matter. So if it's happening with particles, is it happening with us? And so far, no, it doesn't happen with us. It only happens in the quantum world. So let's go back to our cat that we called Quantum. Okay, here's our pet Quantum who's inside this box now. And this is how exactly what Schrodinger said. He said that there is this radioactive substance in the box, as you can see in the picture there. So let's just say it's uranium. Here it is. Here's the uranium. And when this uranium decays, up here is a Geiger counter. The Geiger counter will trigger when the uranium decays, and this thing right here will smash the radioactive substance, and the cat will either die or not die. And again, like we said, the cat is either dead or alive if we open the box. But if we don't open the box, the cat is in what we call superposition. And if you remember superposition, the cat's in all possible states. So the cat's either dead or alive, or he's both. And in superposition, he's in both states.